Welcome back, everybody. Today we're going to take a little detour and make a project that hopefully will help us edit these videos for you, and if you need one, build one yourself. If you're editing videos, this also has some other uses we'll get into later. This original design is by Nicholas Zuza. Yes, looking at his name to make sure I say it correctly. You can find the original STLs and a bunch of add-ons for his original media control dial knob on printables.com. Let's go. We'll take a close-up there real quick, and then we'll get to the parts that you need. And there we go. So here is his page on printables.com. You can find it at printables.com/@ Nicholas Zuza, MIKOLASZUZA. And here are just a few of his models. As you can see, he has several different designs. And the most being, it looks like, just with this knob. Some cool stuff in there. I highly suggest you go look and see what he's got. But we are going to be printing, well, actually making, because we've already printed, this one right here, mostly. I'm looking off at the laptop, so I'm not looking at y'all. This camera's kind of useless, I guess. We were doing the smooth body and the knurled knob, but we were doing one that does not have the play pause feature. You have your choice when you come over here to download the one with the play pause or without. I just went with the solid because I printed this upside down, bottom up, to get that nice play pause. I was assuming you would have to print it that side up and put a bunch of supports underneath, and I really didn't feel like doing that. The other piece this came off of is this add-on base done by Ryan_15988. I had to highly modify this base. I was hoping to upload this modified model back to Printables, but unfortunately I have a .xyz domain and Printables does not support that, so I can't use my email address to register. So I guess I should go get a Google one. If I do that, we will put these on Printables. If not, they will be on Thingiverse or Things. I haven't decided yet once I get to the end of this video, but all the links to the parts will be in there, as well as the link to the code on the GitHub. So let's go back and see what you need at the desk. Alright. First thing you're going to need, tasty cold beverage of your choice. Second thing you're going to need, some patience. No, it's really not that bad. I did spend right about a month making this work. I went through at least 4 different microcontrollers, 2 rotary encoders, a different set of LEDs before I got to this point, several of these, and yeah, this is where we're at. But it serves my purposes. Hopefully it will serve yours as well. The first thing you're going to need is the models. You can see we're going to need the knob, and I did the knurled one in a glittery purple, PETG. You can really do it in any filament you want. We have a recycled transparent, as you can tell, water bottle, PETG for the body. And then we have the base in the same sparkly glitter that we did the knob out of, really just because I wanted to match the top and the bottom. I did consider doing this out of white to get more reflection out of the LEDs, but quite honestly, with the amount that we have, don't need it. So from the original design, I had to make several changes. The first off was I had to eliminate one of the holes here on the bottom, just to make everything nice and clean. I had to put this little square in here to hold the microcontroller. I had to put this little circle to put something in there. We'll get to that. And then I had to add this lip around the outside. This took about 7-8 different designs, get all these holes and clearances correct. It was more pain than I was expecting. So those are the 3 parts that you need. We'll just condense those down for now. You are going to need a microcontroller. And this one, come back over to Amazon, is an ESP32-S2 Specifically, it is listed as Alinan, A-L-I-N-A-N. Let's go over to the laptop. There, a mouse. There we go. I don't know why it's giving me this view, but if you can see, they were pretty cheap. Paid $18.99. It was a 4-pack. Yeah, 4-pack. There we go. Zoom in on them. I went through 4 different microcontrollers before I got to this one. There are some pluses and minuses to this module. You are free to try whichever one you like, but this is the one that ended up working for me for the needs that I wanted. It is an ESP32 S2 Mini version 1.0. It has 4 meg of flash and 2 meg of PS RAM. Also supports MicroPython. The handy thing for me is that it also is recognizable as an HID, human interface device. So a keyboard, a mouse, or some type of physical controller that you touch with your hands. It's a generic driver. It's built into Arduinos, the IDE, Windows, Mac. This should work on Linux. This should work on everything. It just shows up in the instance that we're making it today as a keyboard. So anything that supports a USB keyboard, this should show up. Let's go to the desk cam so I can give you a close-up on this. As you can see, it is a small board. One of the things I did like is it has USB-C. One thing I do not like is it does not have Bluetooth. This is Wi-Fi only, but we are not going to be using the Wi-Fi function either. Didn't build it into it. Don't need it because this is going directly onto a computer. Second thing you're going to need is a rotary encoder. Well, the KY40s, I believe these are. They come on the little breakout board. I got like 5 or 6 of them for $5. I did try a regular standard rotary encoder, and I could not ever get it to work. I've had no problem using this on Arduinos, but on the 4 different ESP32s I tried, it would not work. So I just ended up getting these, and they worked the first time. Plus, there was more code out there for me to reference where people had been using this one with ESP32s. Next thing you're going to need, 3 American quarters. Set those to the side. You're going to need some LEDs, 5 volt. It is up to you, the density that you get. Currently, the code is only set up for RGB LEDs, and honestly, I didn't see the point of needing amber or white. These are pretty nice, and they're very close, very close. This is 31 LEDs. It will go all the way around. I did try this originally with 8 LED strip, which went around twice. This is what we're doing this time. It does have a nice connector that we're going to cut off, and some additional power leads that we're going to cut off. You're also going to need some light gauge wire. This is just some spare that I pulled off of a broken TV. You're going to need some heat shrink for covering wires. You're going to need some diagonal cutters. You're going to need a heat source. A knife would be handy, but not necessary. And you're going to need a soldering iron. And luckily, this thing is not on. Oh, wait, yeah, it's not on. We'll stick it back over here where it needs to be and kick that on. Try not to melt the back of our laptop. And some helping hands would be handy. You can do this without, but I would really recommend getting some helping hands. Not these. These are the Harbor Freight ones. Get some of those nice fancy ones that are all magnetic bases, because this is just a pain. But this is what I got, so this is what we're going to use. All right. So first off, what we're going to need to do is connect some wires to the rotary encoder. Once we get this all assembled, then we'll start looking at code. And this knob, you can program it with any key press that you can have on the keyboard. So that's any button that's on the keyboard. Specifically, the way that I have this set up is turn right, it presses the right arrow. Turn left, it presses the left arrow. Press down, it engages the spacebar. So this works in DaVinci, and I'm assuming Premiere. I don't have Premiere. For scrubbing through video frames, for editing videos, which is the purpose I'm doing this for. It also is handy in YouTube to advance 5-10 seconds at a time and start and stop it. You can reprogram this just to be a volume knob with different key presses in the code. Or if you want to add to this code, this is an idea I've had, I just haven't had the time because it was way more complicated than I expected. Maybe press down for 3 seconds and it changes the mode and switches between them. That should be a pretty easy addition to that. I just haven't got there yet. So let's start with this guy. And we're just going to take a random section of cable. I'm going to make them all the same length. And promptly throw them all over the place, never to be seen again, except for the middle of the night. And we're going to cut off, I think that's right about 100 millimeters. Oh, look at that, we have a ruler. No, I am over. Let's go with right there. Yeah, there's approximately 10 centimeters, 100 millimeters, and that is 4 inches. That should be enough to get from the bottom of where this encoder is going to sit down to the actual microcontroller. There we go. Didn't fly nearly as far. Make sure we have 5. We need 5. 1, 2, 3, 4, and 5. And using these extra colors would be helpful, but it is not necessary. Get rid of that. We're going to strip the ends of each of these wires. Maybe. Go. Right into my drink. Plasticky. There's a second. There's a third. There's our fourth. And our fifth. And we're going to strip the other side because that will be a little more difficult when it's on the board. One day I'll get some proper strippers. Then this channel will be really entertaining. There's one. There's 2. There's 3. And don't worry about stripping off too much. It's much where you can always cut these way shorter. This will just be for convenience. 4. And of course, after they're soldered to the microcontroller, we will be cutting off the excess wire to make it fit. Move this junk over here. All right. So first off, we're going to choose our colors. This is slightly dangerous having all the same, but that's okay. So, first off, we're going to grab some flux to make this easy. If you've never used flux, I highly recommend it. It just makes the heat sink directly into what you are trying to solder. And we will go ahead and get the end of our wires. Set you there. Set there. Whoop, that's a little much. Oh no. Right, set this to the side. Soldering iron is already hot, so that's a good sign. Let's see if I can do this without melting the laptop. All right. I'm going to straighten these guys out. Tin all of them pretty much at once. And stick them over on this rotary encoder. Get it to balance. Smart, I'm using my helping hands in the proper fashion. So we are just going to drop a bit of solder on each of these guys first. That right there is why flux is so handy. It is just instantaneously tinning each of these contacts for me. It's going to make that much easier. Same thing with the wires. It just sucks that solder right up into it. Go. Whoop. Uno mas. Get you out of there. There we go. So now, when we come to stick these guys, it should be pretty quick and painless. Holding it still is the hardest part. Okay, we're just going to alternate colors for now. Grab the right side. See how quick that just sticks right to them. Of course, now that I've said that, I will curse myself. Hardest part of this is actually holding still long enough. Might have to re-hit that one. Let's just do this. Go. Get the last one on here. There we go. Give them a little tug. Make sure they're on there nice, solid. They are. You can see what I've done. I've just soldered them straight to the pins. Now we're going to take some heat shrink, cut it down to sections. There's 4. Need one more. Set that off to the side. Slide this directly over the wires. Spin those around a bit. I really should have tinned those when I tinned the other sides. Go. And this is actually an excessive amount of heat shrink. It's cheap enough. Also provides a little support to the wires. Doesn't hurt, so why not do it? You can see they're all horrendously different sizes. If your OCD requires them all to be the same length, please take them off and yeah, we'll do it. We'll do it. Cut a little one off of this one, and then cut a little off of each of the others, and then back to the first one, and then back to the end. There we go. That looks a little better. on into place. There we go. Now it looks much more consistent and a semi-professional job. Let's hit that with some heat real quick. Just a second there. Now we have those nice and secured to the actual board. Pull that off. Give you a close-up. All right, set that to the side. Next thing we're going to have to tackle is the board, which the pinout. I will post a link to the pinout as well. You always have to make sure you follow pinouts for that specific manufacturer. Now in the programming, this does show up as a different board. That took me 2 or 3 tries to find the correct one. Let's see, we need pins 1, 2, actually 2, 3, and 4, and 12. Reason why are we using those pins? Every other example of code hooking up a rotary encoder to an Arduino or ESP32 specifically used 2, 3, and 4, and it worked out for me, so that's what I went with. 12, I went through several on the boards trying to find one that for SPI, but if this is going to bit bang the SPI, which just means the microcontroller is actually doing the SPI instead of it just being doing its native. I'm sure there's a better pin, but for these boards, 12 worked, and that's what I went with. So the first thing we're going to do, stick this over here, get us a little flux on those pins. And on the front side as well. We're putting an excessive amount here, but that's okay. Just trying to make sure when we stick these wires through, we do not have a problem. Right. So, first off, we are going to take our ground pin. Now, on these guys, there's a series of pins. You have a CLK, stands for click. You have a DT, which is one direction. You have a, yes, the click is one direction. DT is the opposite direction. You have a SW, which is for pressing of the switch downwards. Then you have a positive power and a ground. So we're going to start with the power and the ground. And of course, we made these the same color, so we will start with ground. Now, you want to make sure when you are soldering your board that the microcontroller and the USB port are going to be away from you. So that way the wires are coming through the top. It was going to sit like this, like that so, and the wires need to be going down from the top into it. If you do it this direction, it will not fit into the holder, and yeah, you'll get to do it again. So let's turn it this way so we can see the pinout, which is printed on the bottom. And let's break our helping hands. There we go. Give a little bit right here. On this board, see if our side cam will look any better. Ah, we're upside down. That doesn't work. And you can't see anything. So we will just go back to the desk cam. And I'll just keep doing close-ups. I would have a close-up view of this, but the one that I was using on a phone, I broke my phone, so it is now my phone. Got a little flux on there. Right, so we will start with ground. We're going to add that to one of these ground pins. So I'm going to take it out so I can see the hole. Twist it tight. These things are just enough clearance. All right, we have it through. set the wire so it holds itself in place. Bump the flux. Take our soldering iron. Go. Hardest part about this is most of that solder is feeding down to the other side. Our next wire, going from the bottom up, is going to be our positive power. We're going to put that through our 3.3 volt power. The switch, this rotary encoder and switch doesn't need a lot, and the circuitry on this guy does support 3.3 logic, so it will be fine. Flux, solder, go, much quicker and easier. All right, so working backwards, our switch is going to go into 4 SW for switch. Go. Next one up is DT. Now also the only two that seriously matter when you are starting this together is the 3.3 volt and the ground. The click, DT, and switch you really can put in any order, and 2, 3, and 4 you're just then going to have to go through the code and change it to match what you have soldered. So if you do it wrong, it's not a big deal. You can still just fix it in the code. So we are going to take this one to 3. I'm sure some of you are asking, why didn't you tin those wires beforehand? And I usually do, but when you're dealing with holes this small, that can sometimes make it not fit. All right, there is 3. Take this one off to see what I'm doing. Trying to make sure I get all of the wire through there, which is why you usually tin them beforehand, because one little strand can jump off and short out your pins. Will drive you nuts. Go. That guy is in. The wires to hold itself in place. Okay. Not the cleanest soldering job. Still should be cleaned with some alcohol. But there are all the components. There is our switch and rotary encoder and our ESP32-S2. Right. That just leaves these guys. First off, I'm going to remove this heat shrink from the factory that was put on here because it's covering, for one of the LEDs. And 2, we're going to remove this excess power and ground wire. This is on here because these actually, if you're doing a full, say, 13, 15 feet run of these, you do need some real power. One of these microcontrollers is not going to pass enough to handle it. And of course, it's under this self-adhesive tape. All right, leave the tape on there for now so it doesn't get stuck everywhere. All right. Hopefully, you can find some that does not have these extra power wires, but for this style, this is all, and this was something I had left over. So let's just go ahead and take that one, a little flux here. There's our ground. Probably going to have to resolder the power back. That's okay. Ooh. Actually, we're going to do this a little easier because it looks like they have actually, yep, they stripped the insulation from the wire, folded it over. Okay. No worries. We got tools. There we go. We just clip those extra leads off and save this wire because you never know when you need more. That leaves us with 3 wires left here. On most of these LEDs, this is 2811Bs, I believe. It is 3-wire, 5-volt, 1 for positive, 1 for ground, and your center wire is always the data wire. So we're just going to cut the end off of this guy. Split them up a little bit. We're going to strip the ends. There we go. Get our little pieces out of the way. Let's clean up our wires a little bit by twisting them. All right, so we are going to grab the red on these specific LEDs. The red is the positive and the white is the negative, and green is data. So for our negative, let's start with that. We're going to put this on the second ground. Oop, I already see one thing I'm going to have to clean up. This side. This is really all about the length of wire that you need. You have more, it could make it handier to install this, but also could take up a lot of room inside the case. So let's just stick that one in. Back on our helping hands. Get a little flux. And it fell out. These holes are so tiny. There we go. We're going to have to, this is going to be tricky. Trying to hold this in place by itself. All right, put some flux back on it again. We're going to use, there we go. A weight to hold that in place. Hit it with a little solder. Clean whatever gunk that is off of there. All right, that one is solid. Let's go for our power. Now, on this board, there is a 3.3 volt, which is what we're using as an output for our rotary encoder or digital encoder. There's also a V bus, which is 5 volts coming from the USB into the actual board before it is stepped down to 3.3 volts. So that's where we need to run the LEDs off of. Don't worry, this is not a big draw. Your laptop or computer USB port is going to have plenty of amperage and power to cover this. Hardest part about this is getting these wires to go through the hole. Once again, this is why I did not pre-tin them or cover them in flux. There we go. It is in. So wait to hold the wire in place. Go. Now a little bit of flux on it. Make sure it's not fallen out. Okay. And down to our last wire, which is going to be going into pin 12. Which is on the far side. Right next to our power, 3.3 volt power. Go. That is in. Yes, it is still there. It was some flux. This will be our last bit of soldering. Go. Woo, hot. Okay, we have one we need to fix, which is number 2. It fell out quite a bit. It would work. But I do not like that, so we're just going to heat up the solder, push it through, to solder cool back down. There we go. Let's double check each one of these, give them a nice little tug. They all look good. All right. So there we go. If you've done any microcontroller programming or soldering projects, you will understand these are different on every board. I will take a picture and add it in here at some point so you can see a close-up of this. I actually go over to side camera. And for the amount of light in here, that is really hard to see. And those solder joints look horrible because that is the flux burning. That's why you clean it off afterwards. All right, let's go back to the desk. We should be done with the helping hands. We'll set them aside. Should be done with our solder. And we can turn off the soldering iron because it is ridiculously hot in here. Get rid of our flux. There we go. Clean up a little more junk there. Done with that. Done with that. So that pretty much is all the hard work. So let's go ahead and cut off the excess wire that's coming through the back. You want to try and cut this as close as possible. There's not a lot of clearance in this case. There we go. Promptly be caught in my hands. All right, now we can get to the install. Actually get rid of this wire and this garbage because my OCD in the garbage. All right, get rid of that guy. Come back over to here. There we go. Take this apart. First part of this is we're going to stick it through the case. Whoop. Actually, we're going to take the nut and the washer off first. You'll have to bend the wires slightly to get it in the actual unit. I'm going to put them off at a 90-degree angle. The reason I'm doing this is to give enough space for when this curls around here that they're not all bunched up right there. Might even have to spin it a little bit. Position does not matter. Let's put our washer on there and let's confirm before you tighten this down. Yes. Yes, here we go. So these rotary encoders, see that little nub? Little bit of a nub right there. We are going to need to cut that off. That is so when they are on a PCB, they will stay in place, but we're not going to have that problem. But if you don't cut it, it actually makes this guy sit a little crooked. And the actual knob part rubs. So we'll stick our washer on top. Go. And I'm going to use just some needle nose while I hold the board underneath, tighten this down. Just needs to be snug. That's it. Next step is we're going to take our base and our 3/4. We're going to put them in the little slot and press down. The reason I added this is because there just was not enough mass to keep this thing in place on the table, and it didn't feel good. So yes, you were sacrificing 75 cents, but I think it's worth it. Oh, maybe we're just doing 2. Is one of these a Canadian quarter? Oh, okay, we're just gonna go with 2. Previous model did 3, but that still does add a good amount of weight to it, and those are not gonna come out. I don't see. Take a little micro screwdriver, see if there's some gunk around the edge. Doesn't feel like it. There definitely is clearance. And I know 3 was the magic number. This is probably the hardest part of this. Nope, we're going with 2. I am a liar. So 2 will work. Alright. Now we are going to take this board. We're going to take the rear side with the connector and slide it down under the wall. Like so. Down in there. And just snap the far side in. And now it is firmly in place. So there are quarters. There is our board with USB port going this direction. You can see it pokes through. Our next step is going to push these wires back and attach the LEDs. Now let's see how long this is going to take. And it looks like I need to cut 1 off. There's currently 31 on here, so it appears of this model tape, it is going to be 30. So we will take, do I have scissors over here? I do not. We're going to use our diagonal cutters. Very careful. And it just flew across the room. Always cut on the lines in between the LEDs. We're going to remove sticky back. What a fun word, sticky back. So sticky it sticks to itself. Right. And oh, lordy. Look at that. Here's our first screw up. Don't make the mistake I just made. I just pulled the full sticky back off of it. So we got to split this tape. This is now the most difficult part of this project. Might have to get the razor blade again just for this. One of the tricks is you can kind of scrunch up the corner, but what I'm going to do, take my razor blade. There we go. As you can see, I got some of it up there. Now we will pull off the protective blue plastic. There we go. That's what that should have felt like. Over here, and we will bend this around this first edge. I am aligning these to the top edge of this thing, just to give it a little more space. If you do get LEDs, you cannot get the outdoor or coated or enclosed ones. Either the type that comes in the sleeving. Well, if they come in the sleeving, you can pull them out of the sleeve. But if they are the sealed type that has that little kind of plasticky bubble over top of it, will not fit in here. So there we go. And it lines up perfectly with the back one. you can see the LEDs go all the way around. And that is the complete unit. So now all we have to do is line it up, make sure our slot's in the right spot. Push that one in just a bit. Snap it together. Making sure that the port is to the back, because that's kind of handy. As you can see, that's why I made the hole on this model a little larger, just to cover, to get into that port without it being tough. Every USB cable is different. I haven't noticed this on USB-C, but other USB cables, I have had issues with square ends, round ends, diagonal ends, and some of them fit and some don't. Not necessarily the cable's fault, but whoever designed the device thinking you're only going to use their cable. So our last bit of this is to take our knob. It is notched out with a flat spot, just like the rotary encoder is. So we will line that up and press down slowly. There we go. And there we go. There's our whole unit. Let's go over to the side cam so you can see it. Get this thing in here. Here is the whole shebang. Turn left, turn right, press down. And as you can tell, that click is loud enough the mic's picking it up, even with the noise reduction on. So, there's the first half. There's the first half, the hard part of the project. I'm going to take a quick biological break. We'll be right back, and then we'll install the code on this thing and put it to work. See you in just a second. All right, we are back, everybody. Now we get to get on to the fun part of this. That is programming this guy. And it is going to require two more things. One being, USB-C cable. I have, this is the second one of these I've made. The first one was a USB-C to USB-C. This is a USB-C to A. Should work just as well. Second thing you're going to need is a little screwdriver or a pokey device. You are also going to need the Arduino IDE. I am using 2.2.0. I actually just updated today. And this took about a month of playing with this very simple code to get this to work. I, in all honesty, started out with ChatGPT. And yes, it gave me the framework, but did not matter how much I revised it. There were always problems, and it just took weeks, literally weeks. Besides going through with the different microcontrollers at the same time. So, first we are going to go over to the GitHub page, which is just github.com/printerprawn. Click on video knob. Currently there are only two files in here. One is the .ino, the code we're actually going to use, and the other one is just a reference of the different keys. And I will open this now so you can take a look. You can ignore these defines. Any of these keywords, I guess you would call them, you can use as a substitution. Like I am using the key left arrow and key right arrow for turning left and right. If I wanted to assign a different function to that, say I pressed return every time I turned left and page up every time I turned right, it would do that. There is one exception to this. I'm sure there's more than one exception, but only one that I found. And I copied these straight out of the library. Oh, as there's more additional ones down here I didn't even know. Different backslashes, the function keys, scroll locks, or I have it in here twice. All the keypads, all the separate 10-key keypads, which can be handy if you want to use this for one specific function. And I do believe media keys are in here as well. I have to search through and find them. There are modifiers, all kinds of things. So basically, you have three options. Could modify the code to do 4, but left, right, and press. And this is going to be set up for left arrow, right arrow, space bar. So We'll close the reference and we will go over to the video knob.ino. We're just going to go to raw, capture it all. There are a few libraries you would need to install in your Arduino IDE. So we're just going to have this as a fresh blank file. I'm going to copy it, paste it in there, and everything looks good at this point. All right. So Arduino.h, that should be built in. You will need to install the USB HID keyboard library. I believe it's just under HID. When you go through the library right here, actually let's check. Let's see what HID brings up. I have keyboard, I have mouse, I have a bunch. Conveniently, if you have not used the IDE before, and somewhat confusing, it will pop up down here in the bottom and tell you where the error lies. And usually it is a missing library, or you have multiple libraries. Encoder.h, you're going to need, and fast LED. All these can be installed from the library. That was the other thing I ended up doing with this code, was making sure I did not have to go to any third-party libraries and download them, because that is a pain. And I have found in my experience with microcontrollers, sometimes they work, sometimes they don't, sometimes they conflict with something else. So a lot of times they just get abandoned and people move on. And you discover a problem and it's not going to work and there's no one there to help you. So right here in encoder pin A and B and button are the 3 pins we soldered to. Pin 2, pin 3 for the left and right. And that was CLK and SW, I can't remember. No, SW was switch. And then encoder button went to 4, which is the switch. LED data pin, we used number 12. And currently, the number of LEDs that I have in here is 31. I believe it's at 30. We'll have to double check. But 31 will work fine. You could actually put less or more number of LEDs. If you do less, it's not going to go all the way around. Get this out of the way. All the way around. If you do too many, all it's going to do is go around and then disappear for a little while. So that actually can be an interesting effect. If you want this to go dark, because it is going to be in a standby color, that is how you would do it. Now, it's not going to stay dark the whole time, just in the actual count of speed that it would normally go in. So if you said there were 60 LEDs and this only holds 30, it would go around once, twice, and then lights would pop back on. So that is really the key things to configure, which, if you follow my example, is already there. And then we have, most of this you can avoid. It does have serial in there. Here is under fast LED, set brightness, is where you can set the brightness. So if it is too bright, which I believe this is going to be too bright, we can turn it down. We'll see how it looks. And then it just goes into the standard functions of reading the encoder, left and right. I will show you. So here is the key right arrow, and then a release of key right arrow. You have to put the release afterwards, otherwise it just holds the button down. You can, if you want, put a delay in there between those two spaces and set a time. And so if you do want it to hold on for a certain amount of time, depending on what you're doing, that would be how you would do it. Just gonna take that back out. Okay, there we go. So right arrow, left arrow. The other one to pay attention to is right here. This is for the button, keyboard.right. And here you notice it is different. So, in that library, there is not a space bar. You would think key underscore space bar, key underscore space. No, there is not. You can physically put a little space there, or you can use the raw character code. And this is why I put that list of all the keyword keys and the additional hex codes. There might be more. That was the second example I found, and I just pasted it in there. but 0x20 is for the spacebar. So it is sending that raw down to the computer to let it know that we've pressed the spacebar. The other things that we can change is the colors. You'll see right here, we have blue set for going left. We have yellow for going right. And then there is a standby color. Actually, there is for where is it? Where is it? There is black. I believe it's up above it. I believe currently it's set on green. There's yellow and blue. There we go. When we press the button, it turns green. And I believe the default color is here at the top. It just goes with the previous color that was on. It gives a show, so when it boots up, it goes to its standby color, the last thing it was on last time. Yes. Okay. So, now, let's get this programmed, see what happens. So, this is a bit of a tricky. It is easier, possibly, without the case, without it being assembled, but not by much. So, we have our USB cable plugged in, and we're going to separate this guy. All right. Now, on this microcontroller, which you can barely see in here, are two little switches, one over here and one over here. If you're looking from the USB port, that's why I had to do all this carving out to give you access to the switches. We'll go back to this direction with the USB-C going up. The one on the right here is a reboot or reset. Get my fat finger out. That one there on this side is a reset, and this one on this side is a program mode. So the easiest way I have found to do this is we're going to use our little screwdriver or some other pokey thing, and we are going to put it in here next to the program switch, which is on the side, and press in. I have just felt it go in, and then we're going to stab the cable, which is why USB-C makes this so much easier. If we're successful, we should hear a ding ding noise. Actually, put this down. I am going to press program switch. There we go. There's our ding ding noise. So it is now in programming mode, so it will accept a code upload. So let's see what happens. Now over here under board, hey, if you order this board of the ones I specifically got off of Amazon, and I am going to link in the description, they are named differently on the board than what they show up as. And when you reprogram these microcontrollers, if you use the wrong board, because the pinouts are different on some of them, you can brick them, not hard brick, but soft brick. An ESP32 I programmed with an incorrect board, and the Bluetooth quit working. Learned that the hard way. I'm pretty sure I can get it back, just haven't tried, moved on. So if you notice here, it says this is a DENEYAP, DENEYAP Mini, and it is showing up on COM14. You will probably not have all these unknowns under here. These are my WLED LEDs around my place, so we will select that one. Now we will press the upload button, and let's see what happens. This back so it gets full glory if this works. Fans are kicking up. Even though this is not complex code, and it is only, I think, under 100 lines, it still takes a second. Oh! No, that is not an error. This is a warning. What it is telling us is that we did not use a pin that has SPI built in. I didn't spend enough time going through the data sheet on this actual chip and this board to find out which one it was. I just used number 12. That worked. So it is going to bit bang it, which means the microcontroller is going to be doing all of the heavy lifting for the SPI communication. That's not a big deal because we're not using this thing for anything else. For if you were using this chip in another application where you were using some LEDs and other functions and possibly some other like serial or data functions where data is streaming it back and forth, that could cause it to lag or fail or timeout. There we go. It's telling us it uses 20% of the program space, and it should start uploading any second. Takes a whole 8% of the memory. There it goes. It is. Boom. Now it is giving us a failed upload. That is because this board does not support auto rebooting from the USB cable from the IDE. So all we're going to do is unplug it, plug it back in, and look at that. And now it is detected. Let's go ahead and put our lid back on. Not break it in the process. There we go. So let's spin it right. Ah, yeah. I did not see that little bit of, I wouldn't call that lag. There's definitely a delay that we can adjust in the code, but I kind of like that. Okay, let's go back left. I actually do like that. Although I think we'll probably try and speed that up a bit. Now let's try the press. And actually pay attention. Let's put this someplace we're not going to get a mouse over. And let's look at the laptop. Okay. We are right at the E. So let's turn it right. Oh, it went backwards. Let's turn it left. It went forward. Okay, so I wired the two rotary encoder pins backwards, and that's not a big deal. Let's try press, see if it puts a spacebar. Hey, look at that. All right. So we are going to reverse these two pins, 3 and 2. So now it goes 3, 2 instead of 2, 3. And we're going to have to re-upload this. So we're going to do that. Do it slightly easier way. Screwdriver back. All right, that is pushed in. Let's insert it. There we go. LEDs did not come on, means it's in programming mode. Let's go ahead and recompile, send it up, get a sip of our tasty beverage. There is our warning again. It's a little faster this time. Ooh, anticipation. There it goes. Okay. Once again, we can ignore that failed upload. It actually tells you right here in the warning message, this chip does not support the auto reboot. Right. Put our cursor back right before the E. Let's turn left. And now it goes left. And now you're probably noticing it is not moving very fast. And the other thing is, now our LEDs go in the opposite direction. Let's see if we can reverse that. There was a 50-50% chance that was going to happen. And this is what happens when you do things just raw. I'm sure Fast LED has an option to reverse it, but it is not built into this code. So we're going to do this the easy way. This is really something I should have tested before we did this. Oh, let's not break them. Sometimes the path of least resistance is the correct path. Could go through there and make this a little more elegant by doing it in the code, but look at that. It's just so much easier to do this. Let's try to get it near the top. Okay. See what happens this time. There we go. I like that. I do like that delay. I am going to play around. The question of why this probably moves the cursor so slow, and that comes down into this little bit of code, which once I got the basics of this working, then we ran into this. There is the delay for changing the colors. Chase ID speed. Let's actually take that down to 25, so then it should go faster around. Ah, right here is where we would change this. We could have right here just done, change those plus pluses to minus minuses, and over here from minus minus to plus plus, and the LEDs would have gone the opposite direction without pulling them off and resticking them. But now we know no one's half the battle. What I made this for, let's go over to our down looking camera since we're done with that. I made this for editing these videos for you guys. Sometimes when you're going through whatever video editing software you're using, I specifically am using DaVinci Resolve, you want to go frame by frame, and you have a few options for that. In DaVinci Resolve, spacebar is start and stop, and then you can go frame by frame with the left and right arrows. Kind of hard to see on this gray keys on a gray keyboard, but left and right arrows. So that is specifically why I did this like this, so I could scrub through frame by frame, find out where I want to be, hit the spacebar, it starts playing, make sure that's right, hit spacebar again, stop, back it up to where I want it to be. Oh yeah. I really like that. Oh, I'm messing up my code over here. Not save. The other thing I learned this is really handy for after I had made it and was playing around is if you were watching a YouTube video, and in YouTube you can advance forwards and backwards with your arrow keys, and of course spacebar is start and stop. So if you were watching a video like mine, you can scrub through all the garbage, which there's a lot, I mean a lot, and all the incorrect and just garbage to get to the point that you want, and then say get a phone call or someone's annoying you, you can just smack that button and I shut the hell up. I am sure there are some other functions. You could map these to your media volume keys and the play pause, which would be handy as well. Yeah. I'm sure there are a ton. The other thing I found this was very handy for was in Tinkercad. Because in Tinkercad, many times you need to move something, just nudge it over a little bit. And depending on the angle that you're looking at, you could move it left and move it right. It was very, very convenient. When I was trying to get things really close, I try to work entirely in Fusion 360, but once in a while, you got to do what you got to do. Something quick and dirty helped a lot, was super handy. I'm actually considering making several of these. Another thing you could set this up for is in DaVinci Resolve, or I'm not sure if they have it in Premiere, I'm sure they do, but your color wheels, you normally have those 3 wheels. There you go. You could make 3 of them, and they would be controlling your color gradients. I think that's about it. Yeah. That was a month worth of work. Pretty much every single day, except weekends. A lot of time goofing off at work. Yeah. So I'll catch y'all next time. Feel free to make one. I will get the models posted on Thingiverse or Things. I am not sure yet. Get the models uploaded. The code is already there where you can find it. If you make one of these or you have some suggestions in the coding or features that I could add to this, let me know, and I'll make another. So, y'all have a good one. Catch you next time.